very good morning to Prof and all my fellow friends. My name is Yushi. Today I would like to present about the corrosion control, which I choose one of the question, which is called title Case Study on Corrosion Control in Construction Industry. So basically, I will bring you all attention about a few disaster. We can call it an accident that happened in the past. The first one will be due to the corrosion. The first one will be Silver Bridge collapse, which completed in 1928. And this is basically a very high tension and rookie kind of bridge, which means it have a very long, it will be supported by some bearings and all that. It is one of the aluminium, it was the first aluminium painted bridge in US. So basically it looked like a chain. You can see that look like a chain, and it's very long. Basically it is 2,235 total in length. So the reason of causing this failure is because the corrosion happened in the ice bar design. Actually, the design is very unique because it looked like a chain holding the bridge. So although the design is very unique and very aesthetic, but it had caused a lot of stress and some mini crack formed during the casting of the steel ice bar. So the steel ice bar, basically this is the steel that holding the bridge, and it collapsed in 19 it collapsed. Okay, so the injuries was 9. Okay, 9 people were seriously injured. So this is one of the example. So I would like to proceed with the second example, which is called Patagonia Dam, Tasmania. So it was constructed in 1950. It is a very big dam that we use for generating the hydroelectricity. And in 1990, it identified there is a corrosion happened and in the grouting main remediation and re-anchoring. Okay, so basically this dam does not cause any injuries. It's just that it will cause the whole structure very difficult to be processed, which means they will not remove the anchors. The anchors actually is something that hold the water to be flow. Because as we can see that the force, the water flows, which is very it's in very high power, and this acceleration of water will cause the structure to it's not collapse, just having some corrosion, and they constructed some post-tension anchors. Before that, they only constructed anchors, but the post-tension anchors is something that can hold the tension. And besides that, they will do some long-term maintenance for this dam. And for the third structures, is transmission line, which is completed in 1965. It was having some corrosion as well at this change, which is called, there are some conductors, it is not collapsed yet, but it about to drop. And this is very dangerous because transmission line is something else that can transmit electricity to be supplied to all the houses. So this transit is in Sydney, so the government, they are trying to solve this problem by introducing the optical ground wire, which is which is which is require a lot of causes to do so to solve all this problem. So from the picture, it tells us that the corrosion happened at very small kind of parts. Actually, all this part, although it seems very small, but it will affect the whole structures, especially the foundation. You can see as the time goes by. So mostly all the building they built in the past, it involved a lot of manpower and big project like in 1965. But they will not build the new building again. Instead, they will do a lot of maintenance. They also come out some report every year to determine the corrosion. Yeah. So basically, in this corrosion also does not cause any injuries. It's just that it will cost a lot of budget to maintain. So I would like to proceed to the last construction, which is called the seawall. It's built in New Zealand as well. So basically, a seawall is something else we use to divert nutrient-rich water. What does it mean? Some of the water will be diverted in this direction to reduce the algae bloom, to improve the water quality, as well as reduce the lake fishery, which means this water has to be preserve some ecosystem for the aquatic life. Yeah, this is the purpose of building the seawall. It was completed in 2008. Basically, it's very new among the construction, and the life expected will be 50 years. But there is 1 year it started to corrode, and it was 2014. So basically, they found out that 0.5 millimeter corroded per year. Okay, they expected it was 0.015, but ended up is 0.5 millimeter, which means this may be caused by the environment factors. And actually, the seawater they contains a lot of salts, so it will give rise to a lot of forms of corrosion. Like one of the corrosion is like galvanic. But in this topic, I would like to draw your attention about stress corrosion, because mainly, except for this construction, mostly the construction are built in land. So without so basically the stress corrosion will happen. The first mechanism will be like active path dissolution, hydrogen embrittlement, phloem-induced cleavage. So from the picture, it can tell us that these three pictures are the stress corrosion happen in the building. Okay, so this is the microstructure. So the next is active path dissolution. In active path dissolution, we first start with the crack. Okay, basically when the environment started to being hot, sometimes being cold, the wall will start to contract and expand. So basic crack will happen mostly in all the buildings. Cracks will propagate by localized corrosion at the tip of the crack where metal is locally corroded. So the internal stress, okay, since the building usually they will have facing this stress, like the bridge, the stress is come from you have to sustain the whole building and the structure. So this is the stress come from. The stress will grow at the growing tip due to the formation of corrosion product. So normally it will occur along the grain boundaries. So the presence of the applied stress will open up the crack tip and increase the anodic dissolution rate. So basically, when you have stress, the stress will cause the crack to be propagate faster. Yeah. So crack actually will happen. So stress will be the contributing factors to cause the crack to become bigger. And the crack will be happen is intergranular stress corrosion. Yeah. So the next mechanism will be hydrogen embrittlement. Okay, when the stress comes in and the crack opens out the cracks faster, go very fast through the grain boundaries. And the fracture does not need to lose much, okay? Which means the fracture does not need to lose much material as corrosion product. The fracture will surface display a shiny and brittle feature, which means this is the anodic stress. Just now the mentioned one, the anodic stress happened over here, and it will attract all the hydrogen atoms. Where is the hydrogen atom come from? The hydrogen atoms come from the water actually. As you can see, mostly all the buildings that built for outdoors purpose, it will get in contact with the rainwater. So basically, rainwater it gives the hydrogen atoms will diffuse into the metal and precipitate as hydrogen molecules. So and the interface of matrix inclusion subsequently will reduce the corrosive energy of the solid. So basically, this hydrogen abridgment will be attracted to all these cracks and give rise to those intergranular hydrogen degradation. It will slowly degrade. And lastly, we have the mechanism of phloem-induced cleavage. So this happens when the ductile material is coated with brittle phloem. So like just now the bridge, it contains silver paint. So silver paint, we can say that it is one of the phloem, all right? So the phloem basically will also will have crack as well. So the crack will propagate into the ductile material for a small distance. Let's say it will maybe like in one of the year, it will grow, having the growth like 1 millimeter, and then it will start very fast. So the brittle phloem has been formed by corrosion process. It can reform on the blunted crack tip, and the process will be repeated. Okay, so the brittle phloems are best established as causing phloem-induced cleavage. Okay, the cleavage means something else is like a hole, a hole cleavage. The phloem-induced cleavage process was normally expected to give a transgranular fracture. So, in conclusion, all these mechanisms will contribute to stress corrosion. So, what are the effects and side effects of this stress corrosion? Basically, it will involve a lot of costs of maintenance, okay, every year, which means like the transmission line, it involves a lot of costs to repair the system, and it will cause injuries and death. Okay, let's say if we do not do the maintenance, the accident happened in one day, like the Silver Bridge, it have caused a lot of injuries and death. So besides that, it will cause environmental issues when we do not properly manage the construction, which means when it collapses, we do not manage well, just left it aside. It will cause like the environmental issue, like the bridge collapse into the sea. Yeah, this is one of the environmental issue. Besides that, it will also lose the efficiency of valuable infrastructure. So all the construction, like the Kataguna Dam, okay, like this Kataguna Dam, when it was being under constructed and repaired, usually the water shortage will be, the people will face water shortage. Since this dam is contributed and gives supply to the people in Tasmania, is in Australia. So basically, when we repair it, we need some time since it was built in 1950. It's a very big project. So the construction will be also involve a lot of manpower and will also cut off the supply of water. So what are the prevention steps we can take? Actually, we cannot say it's a preventive Corrosion is like something else we cannot prevent, but we only can go for control. So the first one will be selection and control of material. The second one will be control of stress, and the third one will be control of environment. So selection and control of material, there are something else we need to take note, like the material to be selected, the mechanical properties. So these are the triangle that we have to consider, like the shape of the material, what are the processes involved in the material, and what are the coating to be used to protect the material from corrosion. Besides that, it has to be fulfill the green and concept of green environment. So before we constructing a building, we need to take into account how much this impact to the environment. Does it cause a lot of? Does it cause some damage to the ecosystem? For these two, are the testing that we can do on the material to know that how many percentage of this material can for the mechanical properties. Usually these two are due for the mechanical properties. Okay, this is the table that basically we have. These are the common material that we use for the environment. These are the potential environment that caused by corrosion, and these two are the temperature and the mode that are caused by these. Let's say if we choose carbon steel. So what are the potential of corrosion happen if we use carbon steel? Maybe we will like attract all these nitrates and carbonate environment. Yeah, carbon steel will provide all this environment. Okay, the next will be control of stress. So people, we all have stress as well as the building. We have to reduce, we cannot control the working stress, but we can only control the stress relief, which means the residue stress. Okay, what are the difference between residue stress and working stress? What I understand about working stress is how many stress that object can handle. But the residue stress is like the stress can be released by stress relief annealing. So for carbon steels, it will have a very high threshold of stress. We need to we need to control this stress. And besides that, when we do the annealing, we need to use high temperature, right? So the next is control of environment. By using corrosion inhibitor, we can reduce the corrosion rate. So as we learned the lecture before, these three are the ions that can control the corrosion rate. Since the higher corrosion, the better inhibitor other forms of corrosion happen. Actually, when we use corrosion inhibitor, one thing we need to have in mind, when we try to control stress corrosion, we have to think about whether this corrosion inhibitor will cause any effects on other corrosion. Because some of the cases that happen when we try to control the corrosion, stress corrosion, but uniform corrosion will happen. For the coatings, we have to apply on the surface on the material. The coating, this is called nano coating. Yeah, nano coating is a very new technology. So basically, usually the coating we use is like something else we spray on the material. So the third one will be impede the travel of chloride. What does it mean impede? It's like we try to stop the chloride to propagate by using capillary suctions and epoxy injection and the penetrating sealers. These are the picture that show us that this one we can try to like stop the chloride to travel through the uh, buildings, because chloride is one of the ion to cause hydrogen embrittlement. It's one of the ions that cause corrosion. Yeah, not the hydrogen. Yeah, and besides that, remove chloride. Actually, it's very difficult to do so, but actually we can use some electrochemical chloride extraction method using the potential voltage. So hydrogen, from there we can try to remove chloride, but actually this method is not for a larger scale. For the smaller scale of building can do so. So lastly, these are the mind maps that summarize all the facts that I would like to bring your all attention. So basically, we have mechanism, we have side effects, and the control methods of corrosion. So lastly, all this, actually there are more corrosion that happen in the building. It's just that this presentation, I will only highlight on stress corrosions. So yeah, that's all from me. Thank you.
Okay, thank you, Shirley, for your interesting presentations. Okay, so I would like to offer answer and also uh, Najiha to ask any question you want.
Guys, do you have questions for my presentation?
Ansar, do you have a question, Ansar?
No, doctor.
Louder, please.
No question.
We can't hear you.
Don't have a question.
Again, Ansar. What is your question? If your mic problem, maybe you can write in the chat box so that I can read it for you. How about Najia? Do you have a question, Najia? While we'll wait answer writing his question at the meeting chat. Oh, no question. Okay, Shinley, I would like to ask you regarding these three, I think four event, basically obvious, related to the constructed material. Okay, so one is a dam. So we have dam, we have bridge, and then we do have a electrical tower. So that number three, So the number four is I forget the number four. This one number four is lake. What they call it? This one seawall. The seawall.
Yeah.
And is it? And you say that is a lot of chloride, isn't it? You mentioned there is a lot of chloride. Is it that lake a salty lake, or is lake like in Malaysia? Not salty lake. So have you
Oh,
discovered that this lake Rotoiti uh, is a salty lake,
mm,
or it's just it could be an it's lake? Normal lake is not salty, isn't it? Like a seawater.
oh yeah. Yeah.
So what
Yeah.
what is your finding in this lake? I don't know. I haven't checked it. Is whether that, even though I've been to New Zealand before, but I think if people talk about lake, it should be
I this lake is more like yeah, it's not salty. Yeah, it's not salty. So because you have a lot of nutrient, so from what I'm reading, it's something else like it will supply some water qualities to supply the water quality to the people, as well as it will have some aquatic life. So I believe that mm, like not like sea, because sea basically is more salty, and um usually what I understand is, if I didn't see any seawall, although it's called seawall, yeah, in the sea. So basically, this seawall is actually the name for the wall that trying to trying to like give some blockings, yeah, give some blockings to reduce the algae blooms and restore the lake fishery.
okay.
Mm.
Yeah, because we need to understand the facts. In the lake, basically is not a salty water as like the sea water, and basically it's not due to the chloride attacking ion attacking. It could be something else. Okay, because that's why they are expected in the normal water. No, normal water normally. Um, the design of this what we call it, the wall, seawall, they call it seawall, can be sustained for 15 years, and then expecting a corrosion rate is about 0.015 millimeter per year. And then suddenly when they install that the seawater, they can see that the wall deteriorate very fast, which is 0.5 mm per year. So every year we get the wet loss of the metal of about 0.5. So it's very fast, very fast, very fast. So and what is the reason so behind that is a very interesting, and need to be deep more. So it could be from the MIC, microbial induced corrosion, which is they have a lot of bacteria, a lot of plantains, and also the my bacteria induced for corrosion, anaerobic and anaerobic, eating that the seawall. So that's why that the seawall are been attacking, uh, and uh, and corroded very fast, and corroded very fast, and I don't think so it could it from the chloride ion, because that the lake normally is not salty water, and normally what we do have a lot in the lake normally is the microorganism, uh, which is living in the lake, in the pools and so on, like fungus, all these things are contribute, okay, to the microbial induced corrosion. Okay, that could be the reason of the Oahu division wall lake royalty New Zealand. Yeah, so but you can dig a little bit and see what is the reason, what is the reason behind that. Like if you look at the okay, this is the last one, isn't it, the seawall? So can you go to the previous slide? Dah habis dah habis. Okay, if you look at the previous slide,
Previous slide.
yeah, previous slide. So the previous slide is about the Sydney.
Is it this
The
one?
Sydney tower, isn't it? Electrical tower.
Yeah. Is it this one?
Yeah, I can't see it. Can
Oh,
you?
Prof, can you see now?
Okay. Yeah, I can see now. I can see now. If you can see that, deliver the electricals and corroded conductor drop involve large cost budget to maintain. So if you look at this one, you just see just one part of them. Yes, just one part of them are corroded. Can you see that? The hook to
Mm.
the cable are corroded. So have you discovered what is the reason from the facts, except just corroded metals or corroded cables?
Mm, um, this maybe caused by this is not a stress corrosion. Yeah, this is not stress corrosion. This
So
is maybe.
so what is that? So they have some stress already inside that cable, and because you are basically pull the cable, isn't it? But what the interesting part is, you can see one other part is not corroded, but this part is corroded, isn't it?
Yep.
Uh, so that's the best reason, if you look at these things, so what do you reckon actually? What is your opinion when you see that one part is corroded, another part, and the touching part is not corroded? What have in your mind when you see that kind of event?
Mm,
Have you heard about the galvanized corrosion?
yep. Galvanized corrosions.
It looks like the galvanized corrosion, isn't it?
Mm,
And
yeah.
the hook made from the different material and that cable made from the different material. So they have a dissimilar material basically, this between two. And the even worse of this design is they have a stress and also they have a electrical flow. Okay, so that make that corrosion reaction become even faster, or even worse. So that's why you can see that the corroded uh, drop of the metal piece on the ground. So that's due to that galvanized been attacking and then weaken the metals. Okay, and then at the same time you have a stress, full stress, and also the electrical flow make even worse. So that's why you have a drop metal piece, or corroded metal piece on the ground. So that could be the reason, because we can see the nut is corroded, but the base is not corroded. So which material are corroded means what? Is it the high negativity or low negativity?
Thing is
If you look at this one, so that metal being corroded is the less electronegativity or more electronegativity?
mm, it's more electronegativity.
more electronegativity, isn't it? So that's why
Yes.
they've been, react, been corroded. So that's why if you look at this one, look at the base one is still intact, still the same, but the nut, all corroded. Maybe the nut made from the iron, but the others make from the stainless steel, maybe different steel. So they have a different or dissimilar metals. Basically, these two things. So that's uh, make that the what we call it, the these structures have been deteriorated. Deteriorated. Okay, so due to that wrongly material selection. Okay, during at that time 1965. Okay, so if you look at the previous slide, look at the previous slide, the bridge. Okay, so this bridge basically due to um, uh, that's the bridge collapse. So the bridge collapse. This one basically is due to stress corrosion cracking. Uh, by what actually?
Mm, I think basically is the design, like the
Sorry,
change, the design. Yeah,
the design. You think the
yeah,
design?
yeah. The design is the problem.
Okay, design got problem. So, what is the design? What kind of design make that the bridge become a real problem? Uh-huh.
Mm,
Because you are saying that design is not so good, so we need to know what kind of design design make that bridge prone to the corrosion attack.
mm, what I understand is the design is more like a change. So basically, the whole bridge body is very tough, and usually people not just walk on it. It actually will contain like a vehicle, like the car will run on it. So
Okay.
basically, the design is not able to support the whole
The whole
stress.
pictures, isn't it?
Mm,
Uh-huh. So it's the point of stress basically is the middle of the of the bridge, because the weakest point is basically in the middles. So that's why when you have more load in the middle, so um, the bridge was collapsed, was collapsed. So, but this is aluminium, aluminium bridge, the first aluminium bridge.
yeah.
Okay, that's also interesting, because aluminium basically will not corroded, isn't it? When it
True.
form a passive layer, kan? But
Mm,
yeah, but this time it's about faulty design. Okay, so it's engineering, engineering fault. Okay, that's good. So if you look at the dams, look at the dams. So this one, what do you think is what kind of uh, corrosion, type of corrosion been attacking uh, for this dam?
mm, because then have a lot of like the water, it will carries all the water, and
Yes.
um, they see is more I think stress corrosion. I'm not quite sure from, yeah,
Yes,
not quite
it's
sure.
come from the stress corrosion cracking, but it's not a major. Basically, it's a what we call it, the cause, due to the stress. Okay, but I don't know because they are not mentioning. Is it the mentioning about the concrete, the of the
Yeah,
of
the
the
concrete.
masonry, isn't it?
Mm,
So it could be, I think this one, it could be from the concrete corrosion cracking, concrete corrosion cracking, because that the what we call it, the dam basically made from the huge concrete, and then some of them maybe are not, you know, up to the standard, not following the spec. okay, not follow the specification, so that some of them, been attacking by the concrete corrosion cracking. So it weakened the what we call it, the steel inside the concrete. And then that the water, one of the elements, basically contribute a lot to the destroy the steel. So that could be the reason. And most of the time it's the dam problem because of the concrete construction. And bridge also, if you are basically not following the standard of doing the concrete, uh, to the and also to install the reinforced bar. So maybe you are not put inhibitors, in the reinforced bar. So just simply put inside the concrete, and then even the concrete have a, uncontrolled, because concrete basically is a alkaline base. It's a alkaline base. So that's why when the re uh, uh, steel inside the concrete basically will not corroded because the environment is not acidic. Okay, when the concrete corrosion occur, basically it changed that the alkaline media to the acidic media, by producing a lot of hydrogen gas. Because you know that when the iron or enforced bar, steel bar basically inside will turn into the iron to positive, and then the electrons goes to the uh, OH negative, and then this will release the gas of the hydrogens and also the waters. So that will contribute to lesser the alkaline media to become acidic media, and then encouraging continue eating all the reinforced steel until it's gone or changed into the corrosive product. So that's how that the concrete become weakened, become destroy, okay, due to that kind of effect. So yeah, uh, and then 1950, but during and then after that you go to the 2008, isn't it? So is it current 17,000 don't have that problem? I mean, 1990, 2000s have no problem about the corrosion. So yeah, so before that, the before New Zealand one, so you have the, yeah, Sydney is 1965. It's a long, long time ago. Okay, so I don't know whether in 1990, maybe they have some uh, event related to the corrosion as well, especially on the construction. But anyway, it's good to have this kind of presentation, and I think you should also focusing on the concrete corrosions. As you mentioned in your mapping, and also the type of corrosion will be contribute to that event. Okay, like stress corrosion cracking, yes, and also hydrogen embrittlement, yes. Yeah, helium induced cleavage, also yes. Okay, maybe you can put another one is concrete corrosions. Concrete corrosion. I think that's most important thing, especially to explain the dam. Uh, okay, the dam, and also maybe yeah, you can say design default for the bridge, the design of corrosion. Okay, especially for the bridge. Okay, and the last one is seawall due to MIC, isn't it? Microbial induced corrosion. So that will be answers all the event, corrosion event, and what is the root cause, the damaging structures. And this is very interesting as you know show it the real event. We can look at very carefully. And also another one is for the uh, electrical towers. Electrical tower is not due to the stress, but basically is due to the galvanized corrosion. So if you can arrange that slide according to the type of uh, corrosion, and then the reason behind that, that will be beneficial for every, I mean, for all of us, so that we know that, oh, this is case study, what is the cause, what is the corrosion form, eh, and why this thing happens, okay, and then the mechanism behind that. So it will related with that event basically we talk about. Otherwise, uh, we will become like superficial, not discussing on the related, what we call it, on the related event basically being proposed by you. Eh? And I love your the last slide is the mind mapping. You are summarize everything. This is a beautiful. So I love to see that. Okay, and I think you are very uh, I think growing right now, and also understand better this subject. I can see that. The case study you have there, very good. And then the effect of stress corrosion. Okay, so it's good, interesting. So just to put more, the others effects according to the event, because this is stress corrosion. It could be related with the um, maybe Kuna brick state, and also silver bridge, silver bridge. Okay, so that could be the reason. Okay, and then dam will be the concrete corrosion. Grid, transmission grid line will be on the galvanized corrosion, and also stress corrosion is a combination. And sea wall, basically is due to MIC. Okay, so that's interesting. Okay. This mind mapping being addressed for you. And what do you feel now?
Hmm. Prof asked me how do I feel, is it?
Yeah, yeah, yeah.
I think more relief because I done one of the assignment.
Okay, good, 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 good. Eh? Interesting. So I would like you to revise a bit, revise a bit, and then send it to the iFolio, the PPT, okay, and also the video, separately, so and this is a very, I think, interesting case study, and what I would like you to do is using our knowledge we have, and then with our creativity, and also innovative thinking. So we try to disconnect all the fact we have, and then we summarize, eh? In the end, what is the real reason? Unless you get that fact from the the literatures, or the events, say that. But we also can debate on that. Sometimes they are not really see that what we say, why we are basically make to that judgment. Okay, so that's interesting for you, because in as a corrosion engineers, okay, you have to predict what's going to happen, uh, why this happens, to your constructions, to your structures. And then from that you have to study what is the defect, and what the mechanism or mitigate mechanism, mitigation proposed, proposal you would like to, propose to your boss, in order to solve that problem. So, yep. This is basically will give you some awareness, and also using your creativities, okay, your critical thinking, in order to solve the problem scientifically. Okay, so very good. Basically, I'm very proud of you, Yoshinli, because with that presentation. Okay, thank you so much. So give a clap, everyone.
Thank you, Prof. Thank you,
You are
friends.
welcome.